Hey guys, so figured I'd record the next lesson, which is on resistance. This one should be a little shorter than the other ones. So first looking at current and resistance. Says you can apply the same voltage to different circuits and different amounts of current will flow. Says, example, when you plug in a desk lamp and the current through it is 1 amp, if a hair dryer is plugged into the same outlet with the same voltage, the current is 10 amps. So different amounts of what they call resistance will change the amount of current that goes through. So for a given voltage, the amount of current that flows depends on the resistance of the circuit. So resistance is the measure of how strongly a wire or other object resists current flowing through it. Objects with low resistance carry a lot of current. Objects with high resistance carry little current. Okay, if you think back to the analogy of a river that has a lot of, let's say, boulders or rocks within it, it's going to slow down the water that's passing through it. So it slows down the current of the water. It's almost like more friction within that water. Well, same idea with resistance. If it's got high resistance, it's going to have a lot of friction. It's going to slow down the current. So like water flowing from a bottle, it says if the opening is large, resistance is low and lots of water flows. If the opening is small, resistance is high and little water flows. If you look at the picture on the right here, you can kind of see that. If it's cut open a lot more, the water will drain much faster, okay, because this has less resistance than the one on the left. High resistance, less water flow, okay. So the amount of resistance in a circuit determines the amount of current in the circuit for a given voltage. The more resistance the circuit has, the less current. If you string lights together, the resistance in the circuit increases and the current decreases, making each bulb dimmer. Okay, so as you can see in the picture up here, one bulb, single resistance, full current. So it's got quite a bit of current going through. Light's pretty bright. Then you got two bulbs. The current that's going through is less. Okay, you can almost think of when we're talking about a path of electricity, you can kind of think of it like a traffic jam, and all the cars have to move at the same speed. So if you put in an extra piece of resistance in there, like another light bulb, it's going to slow all the cars down in that entire circular path. So now that those cars, in this case the charges, are going to be all slowed down. Then if you put a third one in, it slows it down even more. Okay, and you can see that the light bulbs are all less dim because of the traffic jam that's happening because of more resistance. So wires are made of materials such as metals that have low resistance. The resistance in wires is so low we can usually ignore it. Okay, so for the sake of figuring out the resistance within a circuit, we ignore the resistance that is in the wire. There is some. That's why wires do heat up. Cheaper wires will heat up even more. I'm sure you felt your wire when you're charging up your phone get pretty hot sometimes. The cheaper, or the wire that has more resistance will cause there to be more heat up in the wire, and it could potentially melt the wire and eventually could even start a fire. So you got to be careful. Make sure that you're using good materials. Okay, and now you just have your quiz. Good luck.